Okay. We're continuing on with this Chapter 7 test review. A piece of junk computer so slow I finally just reset it. Anyway, I'll quit whining. Unless it starts going really slow here again, then don't throw it on the ground. Okay, y squared minus 11y plus 18 over, still acting slow, y squared minus 7y plus 10. And the instructions are to simplify this. Well, to simplify it, step 1, factor the top, factor the bottom. Boy, this is just maddening. Okay, first is both of these are PSD. So factor the top, factor the bottom. Okay. Well, the reason why they're PSD is because we got y squared, y, no number in front of the y squared. So let's look at the top part. Take the number at the end, the 18, and we would ignore signs. So if it was a negative 18, we'd still go with 18. And we'll come up with our 3 columns. We write down all the products give us 18. We got 1 times 18, 2 times 9, 3 times 6. In the S column, we add those. 1 plus 18 is 19, 2 plus 9 is 11, 3 plus 6 is 9. In a difference column, we subtract smaller from larger. 18 minus 1 is 17. 9 minus 2 is 7. 6 minus 3 is 3. Number we're looking for is a number in our middle term, which is 11, which is right here, so we're going to use 2 and 9. Okay, it's going better now. Now the larger number in the P column, which is the 9, this is the ones we're using, will always be the same sign as the middle term, which is negative. Number I circled in the S column, S for same sign, so if this one's negative, then this one will be negative. Okay, let's factor the bottom part now. PSD, I take number at the end, ignoring signs, and we'll create our 3 columns. We'll write down all products give us 10. We got 1 times 10, 2 times 5. The S column, we're going to add those together. 1 plus 10 is 11, 2 plus 5 is 7. Difference column, subtract smaller from larger. 10 minus 1 is 9, 5 minus 2 is 3. Number we're looking for is a number in our middle term, which is 7, which is right here, so we're going to use 2 and 5. Now the larger number in the P column that we're using 2 and 5, so larger is a 5, will always be the same sign as the middle term, which is negative. Now the number I circled in the S column, S for same sign, so if that's negative, then the other one's negative. Step 2, cancel if possible. Well, I can pick the color. They both have a y minus 2, so those are going to cancel. And we're left with y minus 9 over y minus 5. And that's why I entered right here. Okay. Problem number 2. This is the one I was working on when I restarted. I got mad and restarted. Stupid computer. Okay. So we got x squared plus x. So I'm going to get my pen to work. There it goes. X squared plus x over x squared minus 6x plus 5 times x minus 5 over x squared minus 1. Okay. First step. Move that up where I can grab it a little bit easier. Step 1. Factor everything. So this up here is GCF, because they both have an x in common. This is PSD. because we have x squared x, no x. The x minus 5 is nothing. X squared minus 1 is dots, difference 2 squares. Okay, x squared plus x. I'll factor an x out. And I had two x's, took one away, so it leaves me a single x, plus, and this x is gone, and when everything's gone in factoring, you're always left with 1. So that's x plus 1. Okay, now the bottom part of the first fraction. This is PSD, so we take the number at the end, ignoring signs, so we take the 5, and we come up with our 3 columns. We write down all products give us 5, which is just 1 times 5. Add them together, the S column. 1 plus 5 is 6. Subtract them, difference column. 5 minus 1 is 4. Now the number we're looking for is a number in our middle term, which is 6, which is right here, which means I'll use 1 and 5. Now our larger number in the P column that we're using, which is 5, is always the same sign as the middle term, which is negative. Number I circled in the S column, S for same sign, so if that's negative, then this is negative. Okay, that remains x minus 5. Now x squared minus 1. Dots, difference 2 squares. We're going to try to write it as something squared minus something else squared. Now remember, you ask yourself what times itself gives you each piece. For example, x times x gives you x squared, and 1 times 1 gives you 1. Now this is just a formula. So I'll label what's inside the first set of parentheses as f for first. I'll label what's inside the last set of parentheses as L for last. The formula is f plus L times f minus L. So everywhere I have an f in my formula, I'll plug in x. And everywhere I have an L in my formula, I'll plug in 1. F for first, L for last, set of parentheses. So we're going to have x plus 1 times x minus 1. Okay, step 2. Cancel if possible. Well, the only guideline is one's on top, one's on the bottom, and they're the same. Here's an x plus 1, and here's an x plus 1. So those will cancel. Here's an x minus 5, and here's an x minus 5. One's on top, one's on the bottom, and they're the same. Now, there's nothing else I can cancel. So we got x over x minus 1 times 1. When everything disappears in a fraction, you always left the 1 over x minus 1. And our last step is to multiply those together. We don't actually multiply them together, we just put them next to each other. In this case we do. X times 1 is x. And there. Okay, so x times 1 is x. And x minus 1 times x minus 1, you could write as x minus 1 times x minus 1 or x minus 1 squared. Okay, so here, put x and x minus 1 squared. So x minus 1 squared. Type your answer in factored form. I wonder if it wants x minus 1 times x minus 1. We'll try that. Okay, let's take a look at this one. Problem number 3. We got m squared minus 4 over 8m divided by m squared plus 4m plus 4 all over 16m. Now this is dividing rational expressions. We never actually ever divide. We immediately rewrite as multiplication. So the first fraction remains as is, and we'll change the division to multiplication, and we flip a second fraction. Take the reciprocal of it. So it'll be 16m over m squared plus 4m plus 4. And then we just go through our steps for multiplying. And first step is to factor everything. Well, this is dots, difference 2 squares. 2 terms minusing it. 16 you can't do anything with, 8 we can't do anything with. This one is PSD, because we have m squared, no number in front of our m squared. Okay, let's look at the m squared minus 4. Difference two squares, we try to write it as something squared minus something else squared. You ask yourself what times itself gives each individual piece. M times m gives you m squared, and 2 times 2 gives you 4. Now I'm going to label what's inside the first set of parentheses as f for first, and what's in the last set of parentheses as L for last. And this is a formula, so we'll plug in everywhere we have an f in our formula, we'll plug in m. Everywhere we have an L in our formula, we'll plug in 2. So we got m plus 2 and m minus 2. Okay, so this becomes m plus 2, m minus 2 over 8m times 16m over, and we want to use a PSD on that one. So PSD would take the number at the end, the 4, ignoring the signs, and we're going to come up with our 3 columns. We're going to write down all products give us 4. We got 1 times 4, 2 times 2. Want to add them. 1 plus 4 is 5, 2 plus 2 is 4. Subtract them, smaller from larger. 4 minus 1 is 3, 2 minus 2 is 0. Always the number we're looking for is a number in a middle term, which is 4, which is right here, so we're going to use 2 and 2. Now the larger number in the P column that we're using 2 and 2, so they're both the same. So you pick any of the 2's. So our larger number is always the same sign as the middle term. Middle term is positive, so this 2 will be positive. Number with circles in the S column, S for same signs, both positive, both negative. Since the 2 is positive, then this 2 will be positive. Okay, step 2, cancel if possible. Only guideline is one's on top, one's on the bottom, they're the same. Here's an m plus 2, here's an m plus 2. Now here's an m and here's an m, so those are going to cancel. And numbers we handle like we always have. 16 and 8 are both divisible by 8. 16 divided by 8 is 2. 8 divided by 8 is 1. So let me write down what I have left. I have m minus 2 over 1 times 2 over m plus 2. Okay, step 3. Multiply the top parts together. So I got 2 times m minus 2. Multiply the bottom parts together. The 1 drops away, and we got m plus 2. Now we never actually just multiply them together, though. That's the form it should take. So do the fraction. 2 times m minus 2 over m plus 2. And next question. Looks like we got subtracting rational expressions. So let me start a new page. And this is number 4, I guess. We got x squared over x squared minus 64 minus 8x over x squared minus 64. Now our goal when we're adding or subtracting fractions, and these are rational expressions, but they're still fractions, our goal is to get a common denominator. And if you already have a common denominator, then you're going to add or subtract the top parts. So we're going to have x squared minus 8x over x squared minus 64. And then we're going to simplify the fraction. Well, to simplify a rational expression, you factor the top, factor the bottom. So the top part is GCF. They both have an x in common. And the bottom part is dots. 2 terms of minus string it, difference 2 squares. So the top part, I'll factor an x out, and that gives x minus 8. Now the bottom part, we got x squared minus 64. So I'm going to try to write it as something squared minus something else squared. And you ask yourself what times itself gives you each individual piece. X times x gives you x squared, and 8 times 8 gives you 64. Now I'm going to label this as f for what's F for what's in my first set of parentheses, L what's in my last set of parentheses. And this is just a formula. We got F plus L times F minus L. So wherever F is in our formula, we'll put an X. And wherever we have an L, we'll put an 8. So we got X plus 8 times X minus 8. Okay. The next step is to cancel. Only guideline is they're the same, and one's on top, one's on the bottom. So this X minus 8, thought I had red. This X minus 8 cancels that X minus 8. Now I can't cancel those X's because this is X plus 8, which is different than an X. So we end up with X over X plus 8. And that's our answer. X over X plus 8. So X over X plus 8. And number 5 is, okay, subtracting rational expressions. They got different denominators. Okay. This is problem number 5. And we got X over X over, this is unreal, this computer, X minus 3 minus X minus 10 over X plus 3. Well, we need to get a common denominator. Our first step in getting a common denominator is to factor all our denominators. Well, these are factored as much as they can be, so we don't need to do anything there. Next step, you look at each factor. So I'm going to start with the X minus 3, and I'm looking for the greatest number of X minus 3's in any single denominator. Well, there's one X minus 3 here, there's no X minus 3's here. So the greatest number of X minus 3's in any single denominator is 1. So I'll put an X minus 3 here. Then I go to my next factor, the X plus 3, and I'm looking for the greatest number of X plus 3's in any single denominator. There's none in my first one, and there's 1 in my second one. So the greatest number of X plus 3's in my any single denominator is X plus 3. This is insane how slow this is. Okay. There we go. I'll quit whining. So that'd be our common denominator. Okay. Now we had an X minus 3 here. That X minus 3 is still there. The new item we put down here is an X plus 3. So whatever new item you put down in the denominator, you have to put up on top. The mathematical principle behind that is whatever you multiply by the bottom, you have to multiply by the top. Now here we got an X plus 3, and that X plus 3 is still there. The new item down below is the X minus 3. So we're going to multiply that times what's already up there. So this X minus 3 is a new item down below, so I'll put it up on top. Okay, well, up on top, X times X is X squared. X times 3 is 3X. Over our denominator. Minus, I'm going to FOIL this, multiply everything together. X times X is X squared. X times negative 3 is negative 3X. Negative 10 times X is negative 10X. Negative 10 times negative 3 is a positive 30. All over our denominator. Which gives us X squared plus 3 over X minus 3, X plus 3, minus X squared, and always combine together like terms. Negative 3X, negative 10X is negative 13X, plus 30, all over our denominator. Okay, now we have the same denominator, so I want to merge these together into a single fraction. Now remember, if you have a negative, if I can get my color picked, if you have a negative out in front of your fraction, this negative flips the sign of everything on top. So when we merge these into a single fraction, we're going to have X squared plus 3 minus x squared plus 13x minus 30, all over our denominator. Okay, let's combine together like terms. X squared minus x squared drops away, so we got 13x, and 3 minus 30 gives us negative 27, over x minus 3, x plus 3. I would have thought that would have factored. What if I screwed up? If I did screw up, I'll blame it on the slow computer throwing me off balance. But let's enter that in. Okay, 13x minus 27, and x minus 3, x plus 3. X minus 3, x plus 3. Okay, next question. This is another one with different denominators. So we start a new page. I don't understand this. I reset my computer. It shouldn't be slow, in theory. I hear my hard drive just running away, so it's maybe a virus scan's running or something. 3w plus 2. Let's see if I got a virus scan. Online available. I don't know. Oh well. Okay, adding or subtracting rational expressions. First step is you need to get a common denominator. And how we do that is we factor all our denominators. Now there's nothing to factor here, so we can go on to the next step. Okay, got to figure out what our common denominator is. We'll start with our first factor, the 3w minus 2. Now I'm looking for the greatest number of 3w minus 2's in any single denominator. There's 1 here, there's none here, so the greatest number of 3w minus 2's is 1. Then I go to my next factor, the 3w plus 2, and I'm looking for the greatest number of 3w plus 2's in a single denominator. There's none here, there's 1 here, so the greatest number of 3w plus 2's in a single denominator is 1. So that's going to be our common denominator. Okay, now we have to look at what's new. This one had a 3w minus 2. 3w minus 2 is still there. The new item downstairs is a 3w plus 2, so we have to multiply that times the top. Again, the mathematical formula behind it is wherever you multiply by the bottom, you have to multiply by the top. On our second fraction, we had 3w plus 2. That's still there. The new item down below is a 3w minus 2. So whatever we put down there, we have to put up on top. Okay, well, w times 3w is 3w squared. W times 2 is 2w over our denominator. Plus 6 times 3w is 18w. 6 times negative 2 is negative 12 over our denominator. Okay, we got a common denominator now, so I want to merge together these into a single fraction. So I'm going to have 3w squared plus 2w plus 18w minus 12 all over 3w minus 2 and 3w plus 2. So we're going to have 3w squared, 2w plus 18w is 20w minus 12 over 3w minus 2, 3w plus 2. Now, once we get it as a single fraction, we want to simplify. And you simplify by factoring the top, factoring the bottom, and seeing what can cancel. Now the top part, bottom part's already factored, so we don't have to worry about it. Top part, if it'll factor, will be key number. The reason I say that is because we got w squared, w, no w, number in front of our w squared. Now let me look at that over here inside. 3w squared plus 20w minus 12. key number, you take the number at the beginning times the number at the end, ignoring signs. So we got 3 times 12 gives us 36. Now we're going to write down all products give us 36. We got 1 times 36. We got 2 times 18. We got 3 times 12, 4 times 9, and 6 times 6. The S column, we want to add those together. 1 plus 36 is 37. 2 plus 18 is 20. 3 plus 12 is 15. 4 plus 9 is 13. 6 plus 6 is 12. The difference column, we want to subtract smaller from larger. 36 minus 1 is 35. 18 minus 2 is 16. 12 minus 3 is 9. 9 minus 4 is 5. 6 minus 6 is 0. Number we're looking for is a number in our middle term, which is 20, which is right here. So we're going to use 2 and 18. Now we're going to rewrite our middle term using those two numbers. The larger number we're using, which is the 18, will always be the same sign as the middle term, which in that problem is a positive. So we got plus 18w. Number we circled in the S column, S for same signs. So if the 18 is positive, then 2 will be positive. This isn't looking good. I don't think it'll factor. Okay, factor by grouping. First group has a, did I forget a product? 1 times 36, 2 times 18, 3 times 12, 4 times 9. Okay, then subtract them. 16, 9, 5, 0. Okay. If I try to factor out a 3w, then that gives me w plus 6. If I factor out a 2 here, that gives me w minus 6. Notice how this parentheses does not match that. It doesn't work. And actually, I notice that my last term is a negative, which means that my answer had to, or the number I circled had to be in the difference column anyway. Okay, so it doesn't factor. All that work for nothing. Okay, so let's type that in. So we got 3w squared plus 20w plus 20w plus, was it plus or minus 12? Minus 12, I think. Okay, minus 12. Then down here, I'll have 3w minus 2 and 3w plus 2. And let's go to the next question. It'll be interesting to see if I get 100 in this one. Okay, so let's start a new page. Let's see, 4 over m and plus 7 over m squared all over 28 over m plus 49 over m squared. Now always, when this is a complex fraction, complex fraction means you got a fraction inside of a fraction. Specifically, it's a complex rational expression. And we want to get rid of that. We don't want fractions inside of fractions. So our first step would normally be to factor all our inner denominators, which is the m squared, the m, and the m squared. And my mouse is not working right now, but I'd point to it if I could. Okay, well, there's nothing to factor there. So we're going to figure out what our LCM is. We're going to multiply everything by the LCM of all our inner denominators. Now, for figuring out what our LCM is, we're looking for the greatest number. Let me try to close some of these windows. See if that'll speed it up. Stupid computer. I got a fast computer at home, but it takes forever to upload to YouTube for some reason. I've screwed it up somehow. Need to reinstall it. Okay. Maybe that'll be better. And, okay, so we're looking for the greatest number of m's in any single inner denominator. Well, let me use my mouse. This one right here, there's 1 m. This one, there's 2 m's. This one, there's 1 m. This one, there's 2 m's. So the greatest number of m's in any single inner denominator is 2. So our LCM will be m squared. So we're going to have m squared, and we'll multiply that times the 4 over m, and we'll multiply it times the 7 over m squared. We'll multiply the m squared times 28 over m, and we'll multiply the m squared times 49 over m squared. Okay, now when you do that, these m squared is going to cancel. These m squared is going to cancel. Now here we got 2 m's, here's 1 m, so that m's going to cancel. This is going to cancel and leave us a single m. And same thing down here. That m will cancel, and this will cancel and leave us a single m. Okay, so we got m times 4, 4m, plus 7, over 28 times m is 28m, plus 49. Okay, now after you get rid of the complex fraction, you still need to simplify the rational expression. So we're going to factor the top, factor the bottom. 4m plus 7 we can't do anything with. Bottom part, though, I think is GCF. So we're going to have 4m plus 7, and those are both divisible by 7, I believe. And that gives us 4m plus 7. Now after we get done factoring top, factoring bottom, we cancel. So they both got 4m plus 7s, which would give us 1 over 7 as our answer. So 1 over 7. Let's go to the next question. Grab a drink. A pop, that is. Okay, let's take a look at this problem. What is this? Number 8? Okay. We got 1 over x plus 4 plus 2 equals 10 over x plus 4. Okay, this is a rational equation. So our steps for solving a rational equation, first step is we have to, we're going to get rid of parentheses, there is none. Second step, we get rid of fractions. Multiply everything by the LCM of all our denominators. In order to figure out what our LCM is, we have to factor all our denominators. We got x plus 4, and we got, yeah, they are the same, and x plus 4. There's nothing to factor. So to figure out what our LCM is, we start with our first factor, which is x plus 4. And we're looking for the greatest number of x plus 4s in a single denominator. There's 1 here, there's 1 here. So our greatest number of x plus 4s in a single denominator is 1. So we're going to multiply everything by x plus 4. When I say everything, I'm talking about what's separated by pluses, minuses, and equals. So I'll multiply it times this first fraction. I'll multiply it times the 2, and I'll multiply it times the fraction on the right side. There's an internet video of a guy getting so mad at his computer he throws the monitor on the floor and kicks it. Maybe me here in a few minutes. If I thought they'd give me a faster computer, then I'd do that, but I'd probably just be sitting here with no computer. Okay, this x plus 4 cancels that x plus 4. This x plus 4 cancels that x plus 4. And I got 1 plus 2 times x is 2x. 2 times 4 is 8. Equals 10. Now always combine together numbers. 1 plus 8 is 9. Equals 10. Okay, third step. Get everything with an x on one side, numbers on the other. So take the 9 over. You got 2x is equal to 10 minus 9. Or 2x is equal to 1, and then divide both sides by 2, and you get x is equal to 1/2, maybe. Remember, you have to semi-check it. You have to plug that back in the original problem, make sure it doesn't cause any denominator to equal 0. 1/2 plus 4, if I put in my original equation, that doesn't equal 0. And same thing here. Now let me double check myself, because I was getting kind of frustrated with my computer there. Okay. Yeah, 1/2. And I'll go ahead and apologize for the amount of whining I've been doing here. Okay, so I'll say next question. And formula. Okay, I like these. So I'm going to get a new page. And all I can promise you is if I don't get 100, I'll work that problem again and we'll see where I went wrong. Though I've closed some of my tabs, so that doesn't help. I equals 3a over t plus b. And I want to solve this for b. Well, we're going through our 5 steps for solving a formula for a variable. First step is you get rid of parentheses. Don't have any. Second step is get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, so that is our LCM. So I'm going to multiply it times the I, and I'll multiply it times the fraction on this side. So as t plus b's cancel. Over on this side, I times t is it, and I times b is bi. I always like to write those in alphabetical order. And then over here I got 3a. Okay, third step. Get everything with the variable you're solving for on one side, everything else on the other side. So I'm going to take it over to the right side, and then we'll have everything with b on the left side and everything else on the other side. So I got bi is equal to 3a minus it. Remember, when you take anything across your equals, your sign changes. Now our fourth step says if the variable you're solving for is in 2 or more terms, factor it out. It's only in 1 term. So step 5, divide both sides by what's in front of / back of the variable you're solving for. We're solving for b as in Bill. There's an I behind it, so we're going to divide both sides by I. And I'm curious how this test will do it. Those i's cancel, and we got b is equal to 3a minus it all over I. Typically, simplified form in math means a single fraction, but we could split this into 2 separate fractions and have it written a little bit differently. So it'll be interesting to see if it marks this one wrong. Okay, so do my fraction, 3a minus it, 3a minus it over I. And next question. Solve the proportion. Okay, well, this is 8 over 3 is equal to x plus 5 over 15. Different ways you could solve this. You could solve it using rational equations. That'll work just fine. You could solve it using linear equations, because it really is linear. Or you could solve it using proportions. Proportions means you got a single fraction equal to a single fraction. If you got a single fraction equal to a single fraction, then you cross multiply. And if I get my pen to work, 8 times 5, or 8 times 15, and 3 times x plus 5. Okay, so I got 8 times 15 equals 3 times x plus 5. Well, 8 times 15 is 120, I think. 3 times x is 3x. 3 times 5 is 15. Get everything with an x on one side, numbers on the other, so take 15 over. And that gives us 105 equals 3x. Divide both sides by 3. And we get, x equals 35. Okay. Now how you could also do that, just for fun. Since this is a linear equation, our steps for solving linear equation is to get rid of parentheses first. Don't have any. Second step is get rid of fractions. Multiply everything by the LCM of all your denominators. We've got 3 and 15. Our LCM would be 15. So take 15 times 8/3. and 15 times x plus 5 over 15. Well, this 15 is a cancel. 15 and 3 are both divisible by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. 5 times 8 is 40, equals x plus 5. Take the 5 over, becomes a negative 5, and you get x is equal to 35. I wouldn't say proportions is any simpler on that. Okay, time of truth. Submit test. Let's see if I get any wrong. Rational expressions are just challenging. So if you find them challenging, I missed one. Let me go back and work that one. Oh, how disappointing. Hopefully it lets me review it. Let's see. I answered 13x minus 27. Okay, let's work that one again. Assuming I can find my. I was doing so well too. Hundreds every time. Like I say, I'll blame it on the slowness of the computer throwing me off. X over x minus 3 minus x minus 10 over x plus 3. Okay, so we're going to get a common denominator. So we factor all of our denominators. These are factored as much as they can be. So we'll start with our first factor. Assuming my pen will work. Let me use my mouse. Okay, x minus 3. Now I'm looking for the greatest number of x minus 3's in any single denominator. There's one here, none here, so greatest number of x minus 3's is 1. Okay. Then I go to my next factor, the x plus 3, and I'm looking for the greatest number of x plus 3's in any single denominator. There's none here, there's one here, so greatest number of x plus 3's is 1. So that's going to be our common denominator. Okay, so I had an x, this had an x minus 10. We have to look for the new item down there. Here's an x minus 3, that x minus 3 is still there. The new item is the x plus 3, so we'll put the x plus 3 up here. On our second fraction, it had an x plus 3, that x plus 3 is still there. The new item down there is the x minus 3. Okay, so multiply these together. X times x is x squared. X times 3 is 3x. Our denominator stays as is. Minus, and multiply these together. X times x is x squared. X times negative 3 is negative 3x. Negative 10 times x is negative 10x. Negative 10 times negative 3 is 30. All over our denominator. Equals x squared plus 3x over x minus 3 times x plus 3 minus x squared, combine together like terms, negative 3x, negative 10x is negative 13x plus 30 over x minus 3, x plus 3. Okay, now remember, if you have a negative out in front of your fraction, that'll flip the sign of everything inside. So flip the sign of the x squared, the negative 3x, or negative 13x, and 30. So we're going to merge these into a single fraction. So we got x squared plus 3x minus x squared plus 13x minus 30. And this is seeming really familiar. But I must have just dropped the x here if I had to guess. Okay, combine together like terms. X squared minus x squared drops away. 13x, or 3x plus 13x is 16x minus 30 over x minus 3, x plus 3. I think my eyes got off, because I remember 3 minus 30 give us negative 27, which would correspond with My 13x minus 27. Okay, now we always want to factor. This is GCF, because you never know what can cancel. These have a 2 in common, so that gives me 8x minus 15 all over x minus 3, x plus 3. Now, nothing cancels, so that would be our answer, I think. 2 times 8x minus 15, x minus 3, x plus 3. Okay. 90, that's not too bad. That's an A, I think. Okay. That's the Chapter 7 test review.